Okay, so we're going to simplify complex rational expressions. And a complex expression, a rational expression that is complex means that it is a fraction that has fractions within the numerator or denominator, or in this case both. Now I'm going to do this algebraic one here. And we're going to do it by the two methods that you've been learning in class. The first is the division method. We'll go ahead and do the division method on two problems here on this video. And then on the second video, I'll go ahead and do the same two problems by the LCD method. Okay, so here we go. What does it say up here? It says that if necessary, add or subtract, this is the division method, add or subtract to get a single expression in the numerator, and step 2 is the same thing in the denominator, get a single rational expression. In other words, subtract or add to get a single fraction on the top, and subtract or add to get a single fraction on the bottom. Well, that really kind of begs for the common denominator to be found, because in order to add or subtract fractions, you need an LCD, right? So we're going to go ahead and find the common denominator of just the numerator. In the division method, you just work separately with the numerator and then separately with the denominator and put the final results back together again at the end of the problem. Okay, so here I go. I'm going to go ahead and find the common denominator between 2 and y. They have nothing in common, so the common denominator is actually the product of those two terms, which is 2y. So that means I need to multiply the top and bottom of this first fraction by 2. I always multiply by a form of 1 if I'm going to change a fraction. And so I'm going to multiply the top and bottom of that first one by 2. So 2 over 2 times 1 over y will give me a denominator of 2y. And I have to multiply this second fraction by y over y. So that's going to look like this. Okay. And, let's just go ahead and go across here and finish the numerator off, and then we'll work on the bottom. Okay, so this is going to give me 2 over 2y minus 3y over 2y. And now that I have a common denominator, I could just call this 2 minus 3y all over 2y. Okay. Now let's go back and do the same exact thing to the denominator fractions, right? So the common denominator here is going to be 4y, since 4 and y have nothing in common. So I'm going to multiply the top and bottom of this fraction by 4 over 4. And the top and bottom of this fraction by y over y. And now I get this. Once I multiply together, I'll get 4 over 4y and 3y over 4y. By the way, you do not want to get tempted to go ahead and do cancellation at this point. That's addition. You cannot cancel under any other operation besides multiplication. So at the end of the problem, we might try to factor and see if we could cancel then, but not now. Okay, so now I have this. And I'm trying to make this fraction bar darker, because that's the main fraction bar separating this numerator fraction from this denominator fraction, 4 plus 3y over 4y. Okay, now, this is the classic move if you were taking a basic math class and dealing with fractions. To divide by a fraction, right here, is to multiply by the reciprocal. So the division method has us get a single fraction in the top and bottom. And now it applies the basic rule of division by fractions to say that the equivalent to dividing here by this fraction is to multiply by its reciprocal. So this problem now is going to become this. I'm close to running out of room here. Maybe I'll try to keep going here past this line. But right now, if I converted this into a multiplication problem, it would be this numerator fraction times the reciprocal of this fraction, which would be 4y over 4 plus 3y. There you go. Okay, so now what am I going to do? Well, now what I could do, because I do have multiplication, and I don't think I could factor anything here or here out of these binomials, but I could do some canceling. So I'm going to go ahead and cancel the 2y here, and if I cancel 2y out of 4y, I'll get just 2. So the final answer here is going to be, don't forget that you got distribution going on here if I'm going to say 2 times this quantity here, right? So I'll have 2 times 2 minus 3y all over the only remaining factor here. This is really a 1, so 1 times that is 4 plus 3y, and I'd be done with that problem. Okay, let's look at a second problem. So here, if I went and I took a look again, we'll try the division method a second time. If I take a look here, I think what I'll do is go ahead and find the common denominator to the numerator, right, which would just be x. So it's going to be very similar to the last problem. I'm going to go ahead and multiply. I don't need to multiply this fraction by anything. It's already in its common denominator of x. But this second fraction, I'm going to multiply by x over x to go ahead and create a common denominator of x. And that will give me now 1 over x plus x over x. And again, I can't cancel cross addition. But what that's going to allow me to do now, very similar again to the problem up above, is that's going to give me x plus 1. I could say 1 plus x here, which is the same as x plus 1 all over x, right? I'm just adding the numerators over a common denominator. Okay, let's go back and do the same thing to the bottom. So the bottom is this, 1 over 1. The common denominator between 1 and x squared is x squared. So I'm going to multiply this 1 over 1 by x squared over x squared. And the second fraction doesn't need to be multiplied. It already has the common denominator of x squared. So now I get this. I get x squared over x squared minus 1 over x squared. And now I can combine that. Now I got another opportunity to write the big fraction bar there, right? That's the main division bar. And here I'll have x squared minus 1 all over x squared. And because we're trying the division method and we set ourselves up for it, we got a single fraction over a single fraction. We're going to multiply this top fraction by this the reciprocal of this fraction. And I'm going to get this. It'll be x plus 1 over x times x squared over x squared minus 1. And where I got that from is the fact that if I flip this fraction over, because to divide by this fraction is to multiply by the reciprocal. Now we have an opportunity here. We're going to see, just like we would in any other multiplication of rational expressions problem, we're going to see if we can factor this right here and do some canceling. We can already cancel a pair of x's here between x squared and x, but let's see what else we can do. I'm going to try to just squeeze this in down here. And so let's see. Well, actually, I could just keep going here. Well, that is the difference of two squares. So I'm going to go ahead and write x plus 1 over x times x squared over x minus 1 times x plus 1, which is what the difference of two squares factors into. It factors into the square root of this minus the square root of that times the square root of this plus the square root of that, right? All right, and now I can do some canceling. An x plus 1 would cancel, and a pair of x's would cancel. And the final answer is x over x minus 1.